All right, class. Couple of topics we want to look at. One of them is systems of equations. And the second one we will look at is factoring, okay? For now, we are mainly interested in a linear system of equations. So, to explain the general idea, I start with a simple example, and I tell you the methods that we are going to use. So if we have the following. And I'm going to give it numbers. Number 1 referring to the first line, and number 2 referring to the second line. What we're going to do, there are different methods that we can use to solve this. All right, the first one would be graphing. There are other methods like substitution, which we will discuss later on. Also addition. Also known as elimination. So generally speaking, I don't want you to do the method of graphing for the sake of exam, because you really have to be very precise with your drawing to see if there is a solution. But either way makes no difference. Let us start with this simple example. First and foremost, you must graph each line if we are going by the method of graphing. So when you look at the first one, x plus y equals 1, we need 2 points, everybody. And I'm always interested in what? Intercepts. What is, when x is 0, what is y? 1. 0, 1 is called the y-intercept. When y is 0, what is x?
1.
And 1, 0 is called the x. So let us look at the graph of the first line. The first one, 2 points, 0, 1, and 1, 0. Zero, 1, and 1, 0. We're going to connect the 2 points, and we're going to continue indefinitely. And this is the first line. I'm going to call it L1, which is x plus y equals 1. So all we did was graphing one line. Sounds good? Let's graph the second line. The second line, class, I also need 2 points. And again, easy points would be intercepts. So can you give me the x and y intercept? 0, you said x equal to 0, what do you get? What is y? If x, class, an easy way x is 0, just cover it. So solve negative y equals 5, right? So what is y?
-5.
So 0, -5, that is the y-intercept, is that right? Now you're solving for x, right? Cover the y. 2x equals 5, right? So So what do you get?
5 over 2.
5 over 2, 5 halves, 0. That would be the x-intercept. So let's see. This is not to scale, but 0, negative 5. We go down 5 units along the y-axis, and then we have 5 halves or 2.5, comma 0. So 1, 2.5. L2, which is 2x minus y equals 5. Now, is there a point of intersection?
Yes.
Now, when you do the graphing, if you've done it to scale, if you've done a decent job, it's easy to read the point. So do your best to read the point. What is that?
3, negative 1. Oh, 2, 2, negative
1, 2, right? 2, comma,
1.
negative 1. Now, I don't know if I came up with the correct answer or not. What should I do now? Which, plug it into which one?
The first one.
Both. So, does it work with the first one? 2 plus negative 1, is that 1?
Yes.
Let's see. Does it work with the second one?
Yes.
2 times 2,
4.
4 minus negative 1,
5.
which makes it positive 1, adds to
5.
5. So we haven't made a mistake. So what do we notice? We notice that it works if we happen to have intersecting lines. So here's what's happening, class. The two lines are intersecting, aren't they, right? So when do we have a solution when we graph if the lines are intersecting? So I'm going to call this case 1. Case 1, we have intersecting lines. Is everybody clear? If we were to solve for y, we would get to the slope for each line. Is that clear? Does that make sense? If we were to do that, we would notice two lines are intersecting, and therefore they have a solution if they have different slopes. If M1 and M2 are different, doesn't matter how different. If the two slopes are not the same, the lines must intersect in a plane. Does that work for everybody? So M1 and M2 are not equal, that's all. Means two intersecting lines. And what is the solution point of? Intersection. This system is called a consistent system. A consistent system is a system that if we graph, they will intersect, and therefore it has a unique solution. What does it mean? Just one pair, and we're done. So one more time. If we were to do this by the method of graphing, the two lines must intersect to give us a solution. In order for graphs to intersect, all we have to do, check the slopes. If the slopes are different, they have to intersect and therefore have a unique solution. Does that work for everybody? That is the method of graphing, everybody. Case 2. If the two lines are parallel, everybody. what happens? There is no point of intersection, is there? In which case, they have equal slopes, but they have different intersects. A simple example, take a look at L2 and L3. Okay, class? L2 and L3. They have the same slope because they are parallel, but they don't have the same y-intercept, meaning they are really two different lines. In which case, what do we have? Inconsistent system. What does it mean? No solutions. So how do we know we have an inconsistent system? All we have to do, if we are doing the graphing, we look at it, we look at the lines that are parallel. If we solve for slope, for y, the slopes are equal, m1 equals m2. The two lines are parallel, no point of intersection, we're done, no solutions. This is case number 2. The third case, let's see, I have to write it. Case 2. If the two lines are at top of each other, they coincide, so you have really a single line. In this case, not only M1 and M2 are equal, that means they have the same slope, also they have the same intercept. Therefore, it's the same line, it's a single line. In which case, it becomes a dependent system. And it has infinitely many solutions. Which means infinitely many pairs can be the solution. Now, I want to make sure that everybody understands what that means. What it means is that you can pick anything you want for x, but the y, now you plug it in to find out what's the y. Or you can pick anything for y, then plug it in to find what is for x. So it consists of infinitely many pairs. You can pick one of the variables, not both. And the other one has to be calculated. So this is the system if we use graphing. Okay? Let us look at substitution. We are going to look at the same system using substitution. Now, generally speaking, if you're doing application problems, nobody's going to ask you what method. But you have to know enough number of methods, and you have to have enough skills to pick the easier method. Sometimes one is easier than the other, okay? In the case of a substitution, generally speaking, we try to avoid using fractions. As long as one of the variable, either x or y, has a coefficient of 1, you can use that. In this case, you have many choices, okay? But I want you to understand, you really, you want to take the easy way out. So, for example, if I solve for y here, I get 1 minus x, right, class? You're solving for one of the variables, x or y, doesn't matter. Then what do? You plug it into the second equation. So you have 2x minus y equals 5. So what is y now? 1 minus x. Right? Simplify and solve. So what do we have here? 2x minus 1 plus x equals 5. 2x and x gives us 3x minus 1 goes to the other side, becomes plus 1. divide by 3 and x becomes what?
2.
As before, x is 2. Yes? So if x is 2, class, don't go here, and I'll tell you why. Always check with the original equation. Go with the first equation, let's say, and you solve for y. So if x is 2, 2 plus y is 1, what is y? Negative 1. But you're not finished, and it literally takes you seconds to prove yourself that you're right or wrong. All you have to do now, go to the second equation, plug it in. If it works, we're done. If it doesn't work, we made a mistake somewhere. And it takes just a few seconds. Sounds good, everybody? Make sure you check. So, whenever you're done, go back, check with both equations. Since I used the first equation to come up with the second variable, I don't worry about the first equation, I go to the second. This is the method of substitution. Is everybody clear? Let us look at the method of addition. Can I erase this? The method of addition, also known as elimination. Again, it's a very simple example, but the process is identical in any case. In this case, you notice probably that the easiest method would have been this one. Because the idea is that to get rid of one of the variables by making the coefficients what? Opposites. You don't have to do anything. You have positive y and negative y, they cancel each other, don't they? So on the left side you have x and 2x, which is 3x. On the right you have 1 and 5. Adds up to 6. Divide, and x becomes 2. And the same thing, you put it back, and you get to 2 and negative 1. Now notice, obviously this method for this example was easier, wasn't it? But why do we learn different methods? Because sometimes, substitution works better, sometimes addition. There are other methods that we will discuss in the next course, like matrices, Cramer's rule, and the name. All right? Now, what happens when you're dealing with the first case, whether it's substitution or addition, is that you have to work it out to find out. There's no way around it. But in case 2, we said we had parallel lines and there's no solution, right? How do we know this is the case? When we have a false statement. In other words, you simplify, you end up with statements like 0 equals 5, 2 equals negative 1, are you with me? Which is a false statement. On the other hand, as you go through it and you solve it, you end up with a true statement. That means you have a dependent system. So, graphing is clear. If you're using addition or substitution, you solve to get to the answer. You have an answer. It's a consistent system, a unique solution. If you get to a false statement, it has no solution, inconsistent system. And if it gives you a true statement, it's a dependent system with infinitely many solutions. I'm going to do an example of a word problem. By the way, the word problems that we've done, even the stuff that we did last week, everything can be done. Many times that you have possibility of introducing 2 variables, you can do that, and you can do x and y. So whatever is missing, in this case x and y here, and so forth. And that's what happens in this chapter. There was a question that you come across often, and it was asked, so I'm going to cover that as an example of a word problem application problem. Is there any question before we continue? All right. So I'm going to erase this class. Yes.
I'm trying to do solving inconsistent equations. And the computer is like teaching me how to do it a different way. It compares the two slopes, and then it does something. That's where I'm not understanding. It does something afterwards to show that there is no solution. Like, can we try to answer this one?
Okay, let's put it up here. Let me erase it. Okay, give me the question.
It says find the value for k such that system of equations kx minus 6y equals negative 17.
Kx minus
6y equals negative 17.
I'm going to give it numbers. This is line number 1. Go ahead.
And
line
then
number
12x minus 9y equals negative
2. Negative 18.
19.
But the answer, you're not giving me the
No, in number 2, it's 12x minus 9y.
The second formula is 12x.
Okay, 12. So what's the question now? What do we want to do? We want to find k such that what?
K such that the system of equations, those two lines, does not have a solution. So it's like,
Gotcha.
I'm understanding where it's trying to find the two slopes and comparing the two slopes, but then afterwards, I'm totally lost. I don't understand what.
Here's the deal. If we know this system has no solutions, we know the two lines must be, so we make him parallel. How do we make him parallel? Let's find this slope and make him equal. If you're looking at this one, we want to solve for y, right? Negative 6y equals negative kx minus 17. In other words, move the kx to the other side, right? And so y is equal to what, everybody? Divide both sides by negative 6, right? So what do you get? K over 6x plus 17 over 6. And I'm going to call this M1 is K over 6. Do you all agree with that? Okay, leave it. Can you tell me what is the slope here? Negative 9y equals, move the 12x, negative 12x minus 19, right class? Divide both sides by negative 9, so you get y is equal to 12 over 9, okay? 4/3 x plus what?
19.
In which case, what is m sub 2, everybody? 4/3. Now, if you don't want this to have any solution, m1 must be equal to m2. So how do you solve this simple proportion? Cross product. 3 times k is equal to 4 times 6. And therefore k is equal to what? Does that make sense?
Yeah.
So if they give you a question like that, this is how you handle it. Or they may give you the k and say, we don't want this solution, just can you tell us if there is a solution or not? Immediately you solve for slopes. You look at the slopes are identical, therefore there is no solution. Or the slopes are different, therefore there is a unique solution. Sounds good? All right. We're going to look at some quickly an application problem. And here's the general idea about this application problem that I want to do. Class, if you are running or driving or you're in an airplane, the speed by which you're traveling, you're running, okay, you're biking for that matter, you're driving or you're in an airplane, the speed of the airplane and so forth. The wind will have an effect. If you're going in the same direction, you notice that the wind is pushing you. On the other hand, if you're working against it, it's pushing you back. If you're swimming, and you're swimming in the same direction as the current, it helps you. If you're going against it, it works against you. Or if you're in a boat, it's the same way. The speed of the boat and the speed of the current. What happens? In the same direction, the current will help you, right? Does that make sense? So, in general, when you want to set up a motion problem involving wind or current, you set up the rate such that it is the rate of you, whether it's you or the boat or the car or the plane, and the speed or the rate of the wind and the current, such that they get added or subtracted. So here's the question. A boat takes 5 hours to travel 100 kilometers. It takes 5 hours to go 100 kilometers upstream. And in other words, from point A to point B. And it takes 2 hours to return downstream. Obviously, right? So we are interested to know the speed of the boat in still water. In fact, I'm going to add to it, I'm also interested in speed of the current. Now, you can use X and Y, but when it comes to that, I rather use variables that make sense to me. So in case I do not write the definition, everybody understands what that means. B stands for the speed of the boat, C stands for the speed of the current. Does that make sense to everybody? So, here's how we're going to set it up. Going upstream and going downstream. We have the rate, we have the time, we have the distance. So nothing new. Motion problem, right? Okay. When it comes to a case when there is an effect, a wind effect or a current effect, the rate for that, in the case of the upstream, they work against each other. It is always B minus C. It is always B plus. Are you with me? Now, maybe B is given, maybe C is given, maybe none of them, I don't know. But before even I put in the numbers, if there is anything given, I would write B minus C and B plus C. Do we understand it?
Why did you put minus C for upstream?
Upstream, that means you're going against the current. Downstream, you're going with the current in the same direction. Is everybody clear as to the meaning of upstream and downstream? Up, we are going against the current. Does that work for everybody? So it is always B minus C and B plus C. And I highly recommend you write that first, because sometimes the speed of the boat, for example, is given and they're asking you for the speed of the current. So whatever is given, you put in. But before you put in, just put in B minus C and B plus C, or X minus Y, X plus Y. However, if you're writing X and Y, always define your variables. B and C, even if I don't define it, I think it's fairly clear. But highly recommend. All right. Now, is B given? Is C given? Any of them is given? No. Okay. Let's go and work with the time and distance. What do we know about the time?
Well, it's like 5 hours.
Up here? Upstream takes 5 hours, okay?
2 hours.
And this one takes 2 hours coming back, right? What about the distance? Do we know anything about it? What should I write?
100K.
100 kilometers, okay? And by the way, see, class, this is kilometers per hour, this is hour, and this is kilometers. So it is important to pay attention to the units. So what about this guy? Returning. Do we know the distance?
X.
100.
100. Why?
Same distance.
We're going from point A to point B, we're coming back. So it's the same distance. Does that work for everybody?
Yes.
All right, good. Now, can you give me an equation for the first line? What do you think? If we call it number 1, can you give me equation number 1?
5 parentheses b minus c is equal to 100.
Is everybody okay with the equation number 1?
It's just B equals R times C.
Let there be light. Good. How about number 2?
2
C parentheses B plus C.
Okay. Is that working for everybody? All right, class. Now we're going to solve this, and in fact, since you've seen different methods, I'm going to show you a faster way of solving that. You don't have to do it by this method, but if you understand it, eventually you learn with enough practice what way works the best. Now, before we start, what do we do normally? We apply the 5, we distribute it, right? We also distribute the 2, and then we take it from there using some method, right? But do you notice that if we didn't have anything except b minus and b plus, it would be much faster, right? So can you see one easy way would be, I'm going to divide the first one by 5, and I get b minus c
20.
equals 20. So what did I do? I divided by 5. Again, this works for this question. And I'm hoping that as an intermediate algebra student, you can see that and take the fast and easy way. Does that work? What would you do to the second one?
Divided by 2.
And what do you get?
50.
Is equal to what?
50.
And do you see right now that the addition method is going to be much faster, and you get what? 2b equals 70, and therefore b
35.
is 35 what? I need the units. Right? And if you use any of those, what is the current? Speed of the current? V plus C is 50, so what is C?
15.
15. How do you check? Put it back into this equation and to this equation. What is B minus C? What is B minus C? 20 times 5.
20.
So the first one checks. Okay. What is B plus C?
50.
Times 2.
90.
So I checked it in a split second, and that's what I like you to do, because it makes sure that you have it right, so you can move on to the second question. System of equations. Everybody's okay with that? Now, a few more examples will make it perfect, and we're in good shape. I want to go to the second topic of the day, factor. Sounds good? We're looking at algebraic expressions and the concept of factoring. And if we were dealing with simply some numbers, for example, let's say number 20, we know that what we mean by factors. 1 and 20 are factors of 20. What does it mean? If you multiply, you get 20. Or for example, 2 and 10, okay, or 4 and 5. If you multiply 1 times 20, 2 times 10, 4 times 5, so you can say those numbers are factors of 20. Therefore, the factors for 20 are 1, 2, 4, 5, 10, 20. Now, when we do an algebraic expression, it works the same way. A simple example, if I start with 15x squared y minus 35xy cubed, and I say, okay, I want to factor this out. The very first thing that I look for is what's called the GCF. What does GCF stand for?
Great.
The greatest common factor. And the way you do it, first you deal with the numbers. You deal with 15 and you deal with 35. So whenever it comes to factoring, the first step is looking for GCF. Is there anything in common between the two numbers?
5.
5. So everybody agrees that 5 is in common, right? Then you look at the first variable, x. What is this? X squared, and this is x. What's in common?
1x.
Because we go with the smaller exponent. Look at y and y cubed. What's in common?
1y.
Then what do? You divide 15x squared y by 5xy. You follow what I'm saying? What do you get?
3.
3x.
X.
Now if you multiply them, do you get 15x squared y?
Yes.
That's how you check it. In a split second, you can check your work. Minus. Now, I'm going to use a different color. Divide this piece by 5xy. What do you get?
7.
Minus 7. X and x cancel each other. Y squared. Now, if I multiply, do I get negative 35xy cubed?
Yes.
And that proves we come up with the correct answer. So what is the first step of factoring, everybody? GCF. Now, we're going to look at trinomials. And one subject is dealing with the following, where A is 1, which makes it a lot easier. For example, if we have x squared minus 2x, let's start with a plus first. Plus, let's make it plus 8x plus 15. When you're looking at the case where A is 1, you will always look at B and C. What is the value of B, everybody? What is the value of C? Now you look at the C and you cut it into pieces, such that, factors, such that their product, obviously is C, or 15 in this case, and the sum is B. So we are looking for factors here. Product must be 15. And what are we looking here? Sum. For example, we can say 1 times 15, right? But the sum, is it 8?
Nope.
Anything else comes to mind?
3, 5.
So if I said 3 and 5, we can see the product is C and the sum is B. Does that work for everybody? Therefore, this method of trial and error, which takes place in a split second, easily gives us the answer, and it doesn't matter where I put the 3, where I put the 5, and after. Is everybody clear on that, right? It's a trial and error. We're looking for two numbers such that the product is B and C, and the sum is B, and you look at factors of C. I'm not going to dwell on it too much. I'm going to look at the case where A is not 1. We're going to look at a couple of examples. I first pick up an example from the text, and then an example that was asked. So let me see if I can pick up a question here and do it. Now, actually, before I do that, maybe I should mention this factor by grouping, so I have a couple of methods for it. So let us do, we come back to this concept. Let's look at factor by grouping. When it comes to grouping class, anytime you have more than 3 terms, you have to group them somehow. And this one is this is and the way it works, you look at the first term and the second term. If it works, fine. If it doesn't, you look at first and the third one, first and the fourth one, until something gives. Is everybody clear on that? So for now, let us just look at the first 2 and see what happens. Again, we have more than 3 terms, so we're going to go that route. And with that, we're going to discuss in a second special factor. Is there anything in common here?
Same.
Okay, so when we take it out, what happens?
I'm left with x minus 1.
So you get x minus 1. Now, if this is supposed to work, you are hoping that when you do the factoring with the second piece, also the same parenthesis shows up. So you're hoping for x minus 1. Any ideas what we can do here? Negative d. If we take not the d, but rather negative d out, do you see we get x minus 1? Now, if you take plus d, then you get minus x plus y, and then you have to apply a negative sign. So everybody can see what's in common, right? What's in common? X minus y. So all you have to do now, class, just look at what is left of the first piece. What is left of the first piece?
C minus d.
And the second piece, whatever is left. And it's not d, it's negative d. So everything including the sign, and we're done. So this is factor by grouping. Okay? Factor by grouping. Which in the case of a being larger than 1, we will also look at it. Sure. Now, let's actually pick up an example in this area and do the work, because I want to do it by a number of methods. And then we go to special factor. Now we're going to look at the case where A is no longer 1. All right. There are a couple of different ways we can do it. And later on, I will add also the third method. And here's the first one I want to discuss. Again, and in this case, it's fairly simple, class. Let me just tell you how easy this one is. If you're doing a trial and error, first you look at A, and then you look at C. What is A, everybody?
2.
Now, 2 is a prime number. So it makes it very easy. You have no choice but to go with 1 and 2. So you have no choice but to use x and 2x. Do you see that, everybody? And what about C? That is also a prime number, isn't it? So you have no choice but to use 1 and 3. The only thing is, where do we put it? Do I put the 1 here? Do I put the 3 here? Or vice versa? Do I use both of them positive or both of them negative? Are you with me? Because negative 1 times negative 3 is also positive 3, right? So all you have to do, the trial and error, just try and see which one works. So put here 1, put 3, put 3, put 1, put negative, put positive. And it is really not going to take you that long because it's just a basic arithmetic, you can handle it. So when you multiply, the middle term must end up being 5x. So when you do the concept of FOILing, the ones in the middle. All right? So which one do you think will do the job, class? Let's do something that doesn't work. Let's put 3 here and 1 here. Let's see if it works. First of all, class, understand x and 2x, the product is 2x squared. 3 and 1, the product is 3. The one we are concerned with is 5x, right, everybody? What is the product of these two?
6.
What is the product of these two?
1.
X. So they add up to what?
7x.
And you're looking for 5x, right? It really literally took a split second, and I know it doesn't work, right? So let's switch them. Would that work?
Yes.
What is 1 times 2x?
0.
What is 3 times x?
3x.
They add up to what?
5x.
And you're done. So it normally doesn't take long. Of course, when A is large, or for that matter, C is large, it makes it a little bit more involved and a little bit longer. Are you with me? However, you can do it by this method. What I'm going to do, I'm going to look at the second method. Okay. Sometimes they call it AC method. Sometimes they call it grouping. Okay. And so let's see how that works. Now, if you want to go with this, so everybody's done with that, right? So we know the answer. So in this case, you are going to multiply A times C, which gives you what? Right? Now, when we did the trial and error where A was not equal to 1, we did the same thing, except in that case, A was 1, we didn't say AC, right? When A is 1, class, C or AC means the same thing. Now you're going to cut it into 2 pieces, such that the product is AC and the sum is the same thing, B. Are you with me? For example, 1 and 6, 2 and 3, something that works that. So do you see if you put 1 and 6, they add up to what? 7, right? If you put 2 and 3, they add up to what? Therefore, you go back here and you write this as, see how we write it. 5x, we are going to write it as 2x plus 3x. That's how we cut the 5x into pieces. Now, does it matter if I put 3x here and 2x there? No, it works the same way. Both of them will work, class. It will always work. Now, how many terms I have? I have 4 terms. And therefore, I do it by which method? Grouping. So if I group these two together, what comes out?
A 2 and 1x.
So you have 2x times what?
X plus 1.
If I put these two together, anything comes out.
A 3.
And you get 3 times what?
Parentheses x plus 1.
And so the answer is x plus 1 times whatever is left from the first and the second piece, which is identical to what you got. Is that working for everybody? Now I'm going to give you the third method. Okay? Sometimes it makes it easier. Let me put it here. It is really an extension of a grouping or AC method. Now this is for the sake of those who may even have a little bit more difficulty with factoring. It works like a charm always. And here's how you set it up. The general idea is this, everybody. You put AX and AX here and A down here. Are you with me? So let's see what we put here. You already know the answer, right? So class, it's 2x squared plus 5x plus 3, right? What is A?
2.
So you put 2x here, you put 2x here, and you put 2 down here. Do we understand what we mean by AX and AX and A? Sometimes this method works faster. I hope you're interested in learning any method that is given to you. And by the way, on a normal basis, nobody's going to ask you what method. Okay? Except in the case of a substitution, I want to see if you can do it. And it's the same thing with the system of equations. Can you solve it? That's all that matters. Okay. Now, what was AC class? Again, going back. So we came up with 6, right? And what did we come up here? 2 and 3, right? Now, 2 and 3, you can put it anywhere. It doesn't matter where because they are both 2x, aren't they? So, the AC that you found, which was 6, the 2 pieces that you found, you need to, use those. And now what happens is that always this A will go away. Somehow. Let's look at this case, see how it goes away. Can you take anything out as a common factor from the first piece or the second piece for that matter? Can the 2 come out from the first piece? So what do you get? Let's cross it out. What do you replace it with?
X plus 1.
2 times x plus 1. Do you see that? So what happens to the 2? So what do you have left? This will always work. Okay, class? And now I'm going to look at the example that was given by a student. We're going to discuss that. It's a little bit more involved, but it's the same concept. This is the third method. Now I'm going to look at an example that was given using all 3 methods. Okay, class? We're going to do by the first method, which was the trial and error. Let's see how that one works, okay? You open up a couple of parentheses, and you say it's A, and then you work with C, which is 6, right, class? You don't even look at B yet. So the trial and error is this. You look at A and you say, what are the factors, class? 1 and 12, 2 and 6. What did you say? 4 and 3. Okay? You can do the same thing with C. 1 and 6, 2 and 3. And by the way, if it's positive 6, it could be positive 1, positive 6, or negative 1, negative 6. Understand, I'm not going to put the negative, but you know, it could be depending upon what we need. Now, not always, but generally speaking, it's not a good practice to use the extremes. You can use it to see if it works. It's a matter of trial and error. If this number, B, okay, is fairly large in an absolute value sense with regards to these two numbers, probably the extreme works. But when you look at the concept of 6 times 12, the negative 17 is not used, it probably is a better idea to use, and again, this may not work, but it's a trial and error. So start with the smaller. Go with the means, if you will. Those are called the extremes, those are the means. So let's pick up 3z and 4z. Are you with me? Again, this is one method. If it doesn't work, I have to go with 2 and 6, I have to go with 1 and 12. All right? Yes?
Does it matter?
No. Because it's a product of two pieces, which is commutative property of multiplication. So 5 times 10 or 10 times 5. They're the same thing. The first parenthesis and the second parenthesis can be interchanged. All right. So now, again, maybe it's a good idea to start with the means, okay, rather than 1 and 6, and it may or may not work. Okay? So I may need, for the sake of argument, plus 2 plus 3, or plus 3 plus 2, or I don't know, negative. But look at this number. What is this? And what is this? Okay. Because this is positive, both of them have the same sign. In other words, both of them are positive, or both of them are negative. Do you all agree with that? But since this is negative, I have no choice but to go with negative. If I did the positive, it wouldn't work. I can't come up with a negative b. Are you with me? If this were negative, everybody pay attention please. If this were negative, that means 1 positive, 1 negative. Yes? Now which one again we have to try to find out. So you can try putting numbers here, 1 and 6, 2 and 3, 6 and 1, 3 and 2, until it works, and it doesn't take long. Any ideas? What would work here? Anything would work here? So what should I put here? 2 here? So let's see if it works. Everybody agrees that 3z times 4z is 12z squared. I don't worry about the first term. Negative 2 and negative 3, the product is positive 6. We are okay. All we are concerned with is the middle term, right? So what is the product of these two? What is the product of these two? Do they add up
Yes.
to negative 17z? With that. We're going to do it. Now, because the two numbers, namely A and C, are fairly large, let's quickly look at the second method, which is grouping. All right, so method number 2. What is A times C? 72. Is that right, class? So, for example, it's 1 times 72, 2 times 36, and many more, right? Everybody agrees with that?
8
Now,
times 9.
let's discuss that. So, you're saying 8 times 9. So, take a look, class. Let me write this. 12z squared and plus 6. So what goes in between? In between negative 8z and negative 9z. Do you see that? Why negative? Because it's negative 17z. We could go with positive or negative. We choose the negative because the b is negative. And so Can I put these two together?
Yes.
Anything in common?
4.
For what?
Z,
Z times what?
Z,
Times what?
or 3Z,
Continue.
minus 2.
Okay, that's the first one. How about this two? What is it?
3.
What do you think? Plus 3 minus 3.
Minus 3.
Okay, that's better. Times what? 3 what?
3Z
3z. Continue.
plus 2.
Plus. Is it plus or is it minus? Minus what?
Minus 2.
Minus 2. So 3z minus 2 obviously is in common as expected. And whatever is left from the first piece and whatever is left from the second piece, and we're done. So let's look at the third one. Okay? Everybody's okay with that? Take a look at the third one. Class, what do you put in here? What is A? What is A?
12.
12. So instead of X, I'm going to put Z because the variable is Z. Are you with me? I put 12Z here too. And I put number 12 here too. Everybody got that? Wasn't a big deal? What did you find here, class?
-4.
So put it anywhere you like. Does that work? So now, the first one, is there anything in common? The first parenthesis. What? 4? 4 times what?
3 minus 2.
And then we use a different color. What about the second piece? Anything in common?
3
Times 3 times what?
4Z minus 3.
Is everybody okay with what we wrote? Remember what this is. 4 times 3z minus 2 times 3 times 4z minus 3. Is that right? Everybody, what is 4 times 3? So what is left? Is that it? It will always work. Some people find this easier. Okay? I'm going to add one more thing for factoring, and that would be it. Special factor. Right, class? A squared minus b squared is a plus b times a minus b. As we go from left to right is factoring, as we come from right to left is called multiplication, right, class? So how do I check my work? I just multiply. That's all I have to do. Is that right? So it's one of those that we need to know. Okay? Just for the sake of argument, do you remember what was A plus B quantity squared, which is a special product? Do you remember what it was? A squared
Plus 8B.
plus 2AB plus B squared, right? And if I have a negative sign, I have a negative sign here. Is that right? Then we had A cubed minus B cubed, which is A minus B, A squared plus AB plus B squared. I hope you remember these formulas because we need them. And then A cubed plus B cubed is A plus B times A squared minus AB plus B squared. Now class, the first one is called the difference of squares. It's a perfect square trinomial. This is difference of cubes and this is sum of cubes. Therefore, if we come across case that we notice they are special factoring, which is the reverse class of special product, we should have no problem with that. For example, what is x squared minus 25?
X plus 5x minus
So notice this is 5 squared. Therefore, is x plus 5 times x minus 5. Do you see that, class? Again, all you have to notice, if it has two terms and it follows the first, the third, or the fourth. How about, let's say, 8 x cubed minus y cubed. I would rewrite this as 2x quantity cubed minus y cubed, and then I would put it into which one class? If I'm going to give it numbers, 1, 2, 3, and 4. Actually, this would be 20 or 12.
Number 3.
It fits into the 3. So where a is 2x and b is y. Do you see that, class? And now you have a squared plus ab plus y squared. Now, one of the things that I want you to notice, class, you have a 2 here, which you don't have here. However, you have a negative sign here, negative here, positive sign here, positive sign here. Okay? And this guy takes 1. Is that making sense? Now, how about this one? Let's say x squared plus 10x plus 25. Does it look like anything special? Number 2. So something, here's what happens, class. The first one is a square of x. The second one is a square of 5. And this one has a plus sign. So this is probably the answer. Why do I say probably? Because you have to check the middle term. Don't assume this is the answer. Okay? That is one easy way to see the answer. If it fits into one of those special products, now we call it a special factor. Okay, class? Now, because of the limitation of time, okay, and Professor Dupont is going to have another session, I'm going to go over a little bit more factoring tomorrow, and more questions if you have, and also the synthetic division that you have. Okay? So more factoring coming tomorrow. For now, I think we should be in good shape. Sound good? Any questions regarding what you've seen so far? And get very comfortable with those special products known as special factoring. Now, go ahead.
You have to remember those.
Yes. You have to remember in order to do factoring. And continue from there on when we solve the equations in all. Sounds good? So more factoring coming a little bit tomorrow. Have fun, class.